Hi. Today I'm going to show you how to make a simple swing mechanic in Pico 8. Alright, so first I'm going to load up my existing swing cart that I made that just has the outline of the project. We have the base init function, the update function, and the draw function. And inside of each, I'm going to do a few different things. I'm going to start out creating some time and player variable handling, or time handling and player handling variables. In the update, I'm going to have the time handling, so the update for the delta time per frame, taking input from the player for movement, the looking direction of the player, and some simple physics, and then we'll also add in the attacking and such, and do some state handling stuff. Then we're going to be clearing the screen in the draw, drawing the player, the looking direction of the player, and then also the attack of the player. And I think the attack stuff, we could probably put it down here. We have like attacks and such, right? Okay. So to start out, we're going to need to add a time handling variable. We're going to add in two. We're going to add in something called dtime. You can call it like dt if you want, or dtime. And I'm going to add in something called ltime. So what dtime and ltime are, dtime is the change in time between each frame, and the ltime is the time of the last frame. So this is going to start out 0 and 0. And the player variables are going to be the player x, player y. So these are going to start out at, we're going to say 64, 64. And then we're going to have the velocity x and velocity y of the player, because we're going to have simple physics for movement. And those are going to start out as 0. We're going to put in the dx and dy, which for me is the direction x. I mean, you can call it, if you want, you can call it like dir x or dir y. For shorthand, I'm calling them dx, dy. It's the looking direction of the player. And it's going to be 0 on the x-axis, and it's going to be looking positive 1 on the y-axis. So down on the screen is the direction that the player will be looking. I'm also going to add in a state, and the state is going to be in the moving state or the move state or something. You can call it whatever you want. To me, this is just the state when you're allowed to put in inputs for the player, right? So we're going to have an attack state. When you're doing the attack, I'm making it so you can't move until the attack finishes playing out. But you could have it so that way you can attack and move by just not doing this bit. So now that we have these, we're going to update the time function. So we had dtime, right? And dtime is equal to the current time of the system minus the time of the last frame. So the change between the current frame and the last frame is our delta time, is our change in time. And then now we're going to update the last frame time to our current frame. So that way on the next frame, it'll use our current frame right now as the next frame's last time. Now for input axes, the way we're going to do this is I'm going to create two variables called x and y. So local x and local y. These are going to be the this is going to be the value of what the player is inputting for left and right and up and down. So you can think of this as the left and right axis, and this is the up and down vertical axis, right? The way that we're going to do this is we're going to take in, and if you know, moving to the right on a screen, right? So it looks like for you guys that way. Moving to the right on the screen, the x values go up, and moving to the left on the screen, the x values go down. Right, and moving up on the screen, y values go down. Moving down on the screen, y values go up. So we're going to take in the right direction, and we're going to subtract the left direction. And we're going to take the down direction, and we're going to subtract the up direction. And you don't need to write this like this, but what you're going to think about is this value, the right direction, is going to be a positive 1 if you're pushing right. The left value is going to be a positive 1 if you're pushing left. Same for down and up. These are going to be positive 1 and positive 1 if you're pushing them. And if you think about the simple math, if right was 0 and left was 1, then the x-axis becomes negative 1. If you're pushing right and pushing left at the same time, you get 0, so you don't get any movement if you're pushing both left and right simultaneously. And if you're only pushing right but you're not pushing left, then 1 minus 0 is just 1. Right? So it's really simple. I'm gonna put these back real quick. We're gonna create a function that handles this down here. So I'm gonna create a new function. This function I'm just gonna call b. This function is gonna take in a integer, which we're calling I, and all it does is it's just going to return 1 or 0. That's it. So if you're pushing a button, it's going to return 1. If you're not pushing a button, it's going to return 0. So we're going to return. We're going to use the button function, and if you're pushing button I, we're going to return 1. We can do this by saying button I and 1, and if you're not pushing it, we can say or 0. That way, button this b function, it just returns 0 if you're not pushing a button, or it's going to return 1 if you are pushing that button. So up here, the right is going to be b in the right direction in Pico 8, or the right key button is 1, minus left is going to be b 0, right? So button 0. And then the down direction is going to be button 3, and we're going to subtract button 2, right? So that should be pretty easy to show on the screen. In fact, we can print right now, just as a debug, print x. Oh, well, let's make these non-local variables for a second. I'm going to make this just x and make this y. And if I print x dot dot, I'm going to put a comma in quotes, dot dot, and y. And I'm going to put this at, we'll put it at 64. I'll make it the color white. If I run this, now you see when I push up, down, left, and right. So if I just push left, I get -1 in the x, 0 in the y. If I push right, I get +1. If I push left and right, I still get 0. I push up, I get -1. Push down, get +1. Push up and down, I get 0. Push all of them together, all left, right, up, down, I get 0. So yeah, it's a nice, easy way of getting the axis input. So I'm gonna make these back to local again. There we go. So x and y are local variables again. And now we're going to update the player's looking direction. So remember, initially the player's looking direction. Actually, you know what? Before we do that, let's just draw the player position. So we're going to use a circle for the player, and I think I want the background to look like grass. So we're going to use. Well, I'm going to use color 3 anyway. So I'm going to put in 3 into the clear screen. Use circ fill, and I'm going to draw a circle at the player x, player y. I'm going to draw it radius of 4, the color 7. Right, so we have the player position. If I run it, we have the player at 64. Right, so there it is. Circ fill, player x and y, radius of 4, color 7, which is white. Now we're going to also draw in the looking direction. So I'm going to draw a line. This line is going to start at player x and player y. And it's going to go to the player x and player y, which is just a dot. So there's nothing fancy. I'm going to use color 11, which is a light green. This color here, color 11, that's my forward direction. So this is the direction, is the forward direction of the player. So if we run it, we just get a dot, because we need to add in the direction x and add in the direction y. And we're going to, if we do that right now, the direction x and direction y is just 0 or 1, so it's not going to be a very big line. So we're going to multiply it by 8. And there. So now we have a line that is 8 pixels long, and it is the color green, and it looks down the forward direction of the player. All right. While we're at it, we may as well add in the left direction vector, and the left direction vector will be important later. So I just copied the line twice. I'm going to modify the second line here, or actually maybe the first one. I'm going to make it, the left direction vector is going to be red. So 8 is the color red. Instead of adding in the direction x and the direction y, we're actually going to add in to the player x, we're going to add in direction y. And instead of adding in direction y, we're going to subtract direction x. And this is going to give us the left-hand vector of the player. I'll show you how that comes in handy here in a moment, but basically now we have the forward and the left of the player. Now let's update the looking direction. So we're going to say if x does not equal 0. So if x is not equal to 0, if the x-axis is not equal to 0, and y is equal to 0. So if the y-axis input is basically nothing's being input at this moment, but you are pushing something in the x direction. So this means you can't be putting in both x and y simultaneously either. So you'll see how this plays in here in a moment. But basically, if you are pushing something in the on the x-axis, so it's -1 or 1, but you're not touching anything on the y direction, so you're not pushing up or down, then we're going to set the direction x. So I'll put a little space here. Direction x is going to be equal to x, and direction y is going to be equal to 0. So if you're not pushing anything in the y, it's going to be equal to 0. Okay. I'm going to copy and paste this line, and I'm just going to reverse these. This one's going to be x, this one's going to be y. We're going to say if x equals 0, and we're going to say if y does not equal 0. And now if we run this, right? So mind you, this whole entire project will be available to use and look at and dissect. But if we run it now, you can see that if I push a direction, so I'm pushing left, my character is looking left, but their left vector is now looking down on the screen, right? So the red vector is always to the left relative to the green vector, right? Okay. Now we're just going to do some simple physics. Basically, we're just going to take in the vector direction, or the vector value, and the x-axis and the y-axis. We're gonna multiply the player velocity by that amount. So we're going to say, or we're going to add it into the player velocity. So we're going to say Vx plus equals x, and Vy plus equals y. Okay. And then we can add these. We can say player x is plus equals Vx, and player y plus equal Vy. So that's going to add in the velocity into the position of the player. And now if we move around, you can see, oh gosh, oh dear God, yeah, it's very like ice, right? So we're gonna dampen. We're gonna say Vx times equals, and I'm just gonna use a value like 7. Vy times equals, not 7, sorry, 0.7. We don't want to multiply the velocity by 7. We want to multiply it by a fraction. This way it gets smaller every frame. So you can see I can move around now. I kind of skate a little bit, but this way I can change the dampening like such. I can set this to 8 if I want to. And it's not really that I'm going faster, it's that the player is stopping later. For example, if we multiply this by 9, you see it kind of skates around now, right? So, yeah, we'll make this, I'll make it, let's see, does 8 feel right? Yeah, it doesn't feel bad. Okay, cool. And I don't want the left vector to be so long. So instead of multiplying it by 8, I'm going to multiply it by 4, maybe. That's the red line there. It kind of feels easier to tell which direction the player is looking. And the cool thing about this is you can't change direction once you're pushing a direction. So if you're moving right, for example, I can move up and down while still looking that direction. So as long as I'm holding that direction first, I can still move. And notice even though I'm moving up and down while I'm moving right, my direction doesn't look up and down. Same thing if I move down. If I start moving left and right, you notice I look left and right. But if I move down and I push left and right, I keep looking down. Right? So This might be easier to see if I like divide this by 2, for example. And if I move down, you can see even if I move left and right, it's still looking in the down direction. Great. So here, I'll remove this. Now let's handle the attacking, okay? What we want to do is we want to detect if we are pressing the attack button. So I'm going to have a few more variables. First, I'm going to have a variable called ATK for attack and C for counter. And I'm going to have another variable called ATKT for the overall attack time. So this one is kind of like a buffer. It's like a little bar that'll fill up. And this is the maximum size of that bar. So attack counter, attack total time. And these are going to be, well, first the attack counter starts empty, so at 0. And maybe my total attack time for now, just for testing, we're going to make it like 1 second, right? So if you attack, it's going to take 1 full second for the attack to play out. And, we're going to make one more variable, which is called APC. Now you can call these whatever you want. This is just what I like to call them. APC for me stands for attack percentage, or attack percentage of completion. And this is going to start out at 0% because we haven't started attacking, so we are 0% complete with the attack. This is important because when we do the function that we calculate the position of the damage of the attack, I'm using a percentage to determine where along in the timeline of the attack is like the position of the damage being done. So here we go. So attack. I'm going to say if, and my attack button is maybe going to be the X button, so I think that's button 4. I'm going to say if button, in fact, yeah, I can just say, I can say if button 4, then, and I'm going to say if button 4, well now we're in the attack state. Now, so we didn't actually need an attack state. We could just have a Boolean variable or something. We can just have a variable that says attacking is true, or that we're currently attacking. And then you could have stuff like you're moving and attacking at the same time. But for right now, what I'm going to do is I'm going to do this. I'm going to say if state is equal to move. So if you're able to move, then all of this stuff can happen, right? So there we go. And I'm going to say else if state is equal to attack, then, and then we're going to do the attack state stuff, right? So there you go. Instead of this if button, then whatever, I'm going to say if, and I'm just going to put little parentheses around it like that. So if you're pressing button 4, then we're going to say state equals attack. Cool. So if you push the 4 button, then you're now in the attack state. When you are in the attack state, we are going to add the delta time into the attack counter. So this attack counter, the counter is counting up time, and this is the total time. So we're going to also get the percentage from dividing the current time by the total time. So we'll say attack counter plus equals delta time. And then we'll say attack percentage is equal to the attack counter divided by the attack total time. And then I'll just have a simple if. I'll just say if the attack counter is greater than the attack time, which you could also just say if the attack percentage is just greater than 1, right? This is something simple as well. Then, and you know what? Yeah, why not? So we'll say if it's greater than 1, then we are no longer in the attack state. Now we finished the attack. So we're going to say the attack counter is reset back to 0, and our state is now back to being able to move. Cool. All right, and I'm just gonna print something here. I'm gonna say print, and I'm gonna say print the state. I'm gonna print it at 2.2. I'm gonna print it in the color white. Cool. So you can see in the upper left now I have the state, and I can move around, and if I press the attack button, oh, looks like Z was actually button 4. So you notice it doesn't even do physics, or it doesn't even let me do anything until the attack's over, but it shows the attack state when I push the button. So what I want is I actually want to move these physics. I want to move this out of the, but I want to leave this in. The velocity is still going to be equal. You're still going to add in the, for the move state only, you're gonna add in the X horizontal axis into the velocity of the player. But I'm going to move out all the physics stuff, just dampening and actually adding it to the position, because it's still going to be happening. So there's going to be update physics. Oh gosh. Cool. Okay. And there's going to be add axis to velocity. Cool. So we're adding in the axis to the velocity if we are able to move. Otherwise, we're still just updating physics anyway. So I can move around, and I can go into the attack mode. But when I do, I'm no longer allowed to do any kind of inputs. Right? So now that we're in the attack state, we want to actually show an attack, right? We need to show the attack. So I'm going to create a new function down here. This function down here is going to be called, you can call it whatever you want. I'm going to call it damage position. This is the position of the damage being done. And what you might give it, you probably give it like the player object, or you give it the player position or something. Since my variables are global, I am not really needing to pass anything into it, but we could just pass in player X and player Y or something. Okay. So down below here, the damage position is calculated. Well, first we're going to create a new X and a new Y. These are going to be our outputs. We're actually gonna return these values. We're going to return x2 and we're going to return y2. And this was intended to be y2. Sorry, so x2 and y2. And the way we calculate it is we're going to take some percentage, which is the attack percentage, and we're going to multiply it into a little function that gives us something based on the player position. So, and it's a good thing we figured out how to get the players left and player right, right? So let's do a simple attack that's directly in front of us. X2 would be equal to the player X plus the direction X, and we'll say times 8. And then Y2 is going to be equal to the player's Y plus the Y direction that they're looking times 8. So we're gonna multiply out a position in a direction by 8 pixels out in front of the player. And this is the direction they're looking, right? This is their forward direction. And so if we were to now use this when we're drawing, so down here we're going to say if the state is equal to attack, then, so if we're in the attack state, then we're going to draw the damage position. So I will say local XY, which we have up here. These are local, right? This X and Y. Yeah, these are local. So we're going to create 2 new local X and Ys. These are going to be equal to the damage position function. So the damage position function is going to return to us basically a point that's 8 pixels out in front of our player. And I'm going to draw a little circle there. So that's going to be at position XY. and it's going to have a radius of 2 and the color red, 8. So you can see that when I press the attack button now, it puts a little red dot out in front of me. That's where the damage is being done. We want to animate this point. Right? So how do we animate it? Well, that's where we use the percentage, the attack time percentage. We're going to multiply it into a position, and that or into a vector, and that vector effectively being animated by the attack percentage each frame is going to move a point across the screen. So we have this is the player's forward direction, right? This entire bit here, all of this in parentheses, that is the player's forward direction 8 pixels out ahead. Now, I'm going to start my attack to the right and I'm going to move left. So how do we do that? Well, we can subtract the left vector. Well, how do we calculate the left vector before? Let's actually create, let's rename some variables. Instead of dx, we're going to keep it dx. We'll just remember that's the forward. So I'm going to comment and say this is the forward direction, or the forward vector. And I'm going to create something called Rx and Ry. This is the right vector, right x, right y, just so that way we can remember it. And if you're starting by looking down, well, your right, the player's right is going to be to the left on the screen, which is going to be -1. So -1, 0. And if you notice, that's pretty much the formula we did earlier, right? You swap the y, you make the y the x value of the forward, and then you make the x the negative of what the y is for the forward, right? It's a very simple formula to create the right vector. And we can do that here as well. When we change the looking direction, right here, we can just say Rx is equal to, actually, no, we can just put this outside of it. We can just say Rx is equal to negative dy, right? And Ry is equal to dx. So the direction x, the forward direction x, becomes the right y, and the negative direction y becomes the right x. And so this here, we're gonna call this calc right vector. This is important because it's going to play into our damage animation. Down here, when we're drawing the line, the red line, now instead of subtracting dx, we can just add in rx, right? In fact, we can just add in ry right here. Yeah, this should be ry. We're going to add in the right y to the player's y. And then here, we're going to add in the right x into the player's x. We should get the same thing. Look at that. So the right vector is still facing in the right direction, because here we're adding the forward vector into the player's position. Here we're adding the right vector into the player's position. I know it's confusing because we have dx. You can rename all of these if you want to fx or something for forward vector x and forward vector y if you want to. Or you can even say like forward x, whatever you want. Okay. In the damage position, now that we have a vector that is 8 pixels out in front of the player, we're going to move to the right, let's say 8 pixels, and then we're going to animate to the left. So I'm going to add in the I'm gonna add in the right x. Yeah. I think that's right. Yeah, we're going to add in the right x times 8. I'm going to add in the right y times 8. But now we're going to subtract. So this is how you have to think about it. We have the vector that's 8 pixels out in front of the player, right here. We're now moving over to the right in front of the player by 8 pixels. And then we're going to move left. So we're going to subtract the right vector now. We're going to move left, so we subtract the right vector to move left. And we're going to subtract this, but we're going to multiply it by, say, 16. And we're going to multiply that by the attack percentage. So it's going to start out 8 pixels in front and 8 pixels to the right, and it's going to move left 16 pixels times the attack percentage. And this formula right here is basically, it reads, yeah, 8 pixels out in front, 8 pixels to the right, move to the left 16, but some percentage based on the attack time. If we do this and I attack, you see it slides a point from my front right out in front of me. If you notice, it kind of starts with this weird, there's like a hop, boop. So we gotta figure out what that is real quick. It starts out as 0. So that's the issue. It starts as 0, and that's what it's returning. So let's just make this. Let's just say local. There. There we go. Still doing a little bit of like a blip. I think it's because when we start the attack, it's probably because there's something up with the attack percentage. So the attack percentage is, I see. So when the attack percentage goes above 1, we need to also reset the attack percentage. So if I set APC is equal to 0 as well, we're not going to get that anymore. There you go. See, perfect. Now our attack's just really slow. So that's why we have this attack time up here, so you can tweak it. Instead of being 0.1, we're going to make it like 0.1. So boom, boom, boom. But if I hold it, I keep doing an attack. So I don't want to keep going into the attack state if I'm holding down attack. So what I'm going to do is well, first of all, we're going to say if you push, we're going to use the button push. That way it's not as, there you go. Got to make the sound effects. All right, I think that works. And we can even make it a little bit slower if you want, like 0.2, so it takes 0.2 seconds instead of 0.1 to do the attack. There you go. Feels appropriate, right? So we're animating a point. Now what if we want it to be an actual swing, so that way the swing goes around the player? All right, so we're going to animate first going up one side of the player and then going in front of the player. I'm going to start on the player's right-hand side. So this is going to give us kind of a piecewise function. We're going to have two parts. Part 1 is going to be determined by like the first 50% of the attack, and the second half is going to be the second 50% of the attack, right? So here's how we'll do this. We are going to well, these are going to start as 0 again. So hold on, let's move this over here. We're going to say local x2 y2 equals 0. We found out that this wasn't actually the issue earlier, that setting these to 0 wasn't actually a problem, because it was just that we weren't clearing out the attack percentage whenever we left the attack state. We're going to say if the attack percentage, I'm sorry, the APC, the attack percentage, is greater than, is less than 0.5. And this is all tweakable, right? It doesn't have to be 0.5, but for my function, half of the attack is going to be on the side, the other half is going to be up at the top. We're going to say else and then end. So if it's less than 0.5, it's going to do this up here. Otherwise, it's going to do this down here. We're going to move this. All right, so the part that we already have is going to be what happens if the attack percentage is greater than 0.5. Now, if you notice, it's going to do something funky here where the 16, basically once this is greater than 0.5, we're already going to start out like halfway in front of the player. Oops. Let's see, we do anything funky? Oh, I need the equal. Now, if you notice, only half the attack goes, and when I attack, it starts out already in the front middle of the player. It doesn't do the full swing anymore. So we're going to multiply this by, I'm going to divide it by 2, divide this by 2. Let's see if this works. This does not work. Don't listen to me. I think we can just subtract. Yeah. We're going to say APC minus 0.5. Minus 0.5. There. So after we get past 0.5, basically we're gonna act like we are not all the way through the attack percentage. Let's see if this works. It does not. All right. One moment. Let me look at my swing demo. So if I look at the intermediate one, go down to damage position. Oh, actually I want to look at the advanced one. We go down here to advanced damage position. So let's try this. Let's see what this does. All right, if I copy this, we're going to go back to the other program real quick. And we're going to modify this damage position function like this. Boom. All right, so if APC is less than or equal to 0.5, let's just try this out. So instead of O.x, we're going to say PX for player X. That's what that was. Instead of O.dy, it's just dy. This here, player X, player Y. There is no O.dx. There's no O. anything in this version. Okay. And, oh, it looks like I did do something similar here. Yeah, so I subtracted 0.5 from it to kind of start it back. And we will see how this works. This also might have been done in a janky kind of way as well. But now we don't have an LX. LX was my left X. In this case, we're going to add the RX and add the RY. And I'm going to add RX and add RY. And over here, I'm going to subtract RX and subtract RY. Now, let's just see how this works. X2, Y2, X2, Y2. Okay, and there we go. So here I'm getting an animated position that starts to my right and it swings out in front of the player. Right? Yeah. So right now we have a function basically that if the attack percentage is less than 0.5, it takes the player's position, it adds in your right vector, and times 8. So it's going to start out to the right of the player direction, and then it's going to add in your forward direction. So it's going to start out with a pixel on your right side. Let's see, we're going to do it like this. So on the player's right side, it's going to start out with a pixel and with a point 8 pixels over, and then it's going to move in their forward direction by 16 pixels ahead, multiplied by the attack percentage. So it's going to move forward, and then once it gets to 0.5, so it'll only move forward 8. Yeah. So basically it'll move forward 8 pixels at most. And then once it's greater than that, so now it's moved 8 pixels forward, it is now going to be at the player's forward direction plus their right direction times 8 plus their forward direction times 8. So the player's right and forward get added together. Now we're going to start subtracting the right vector times 24. And we're going to multiply that by the current attack percentage subtracted by 0.5. So starting out in front of you to the right, you're going to start moving looks like 12 pixels ish. We'll see how this works. I mean, it looks like it works proper, right? So there's that. Now we can start drawing some pictures. I'm gonna create. Let's see. I'm gonna steal some art from my other project. I'm gonna just take all of this and I'm gonna copy it and I'm gonna put it in here just so I can get some animation for my character. So I just have a left and right sprite, and which is also going to be my down sprite. You can have a separate one for down as well. And I'm going to have a behind right sprite, and then I have the sword. Now, if you want to actually use a image rotation function, be my guest. And actually, I think I just used an image rotation function for my other one. If we go into here, oops. In my advanced, yeah, I have this function here that's ghem and freds 72. They posted this in the BBS for the Lexilawful forums. This rotated sprite function, right? And I don't think it requires anything else. It's just this function. You give it a sprite, an X and a Y position for the upper left, and then you give it or I think for the center. Yeah, for the center point, it rotates around, and then you're going to give it a angle to rotate by, and you give it the width and the height of the image. And it draws that rotated, and we would only need to draw it by 90 degrees. Now, another way you could do it is you could just have these two images, and you just determine which one you're drawing based on the forward direction of the player and the left or right direction of the player. Right. Let's well, first let's just draw the player. So, all right, I have some artwork here. I'm going to give my player a sprite value. So let's see, call this. I don't know. We're going to have something called SP for the player sprite. That's going to be equal to sprite number 1. We're going to have something called the animation length. So we're just going to call it the number of frames. The number of frames for my animation is going to be just 1 frame long, maybe 0 frames. The frame time, maybe number of frames, frame length, animation time. We're going to call it, I'm going to call it FT for frame time. Each frame is going to take like 0.1 seconds or something, or initially just 1 second for a frame. Who knows? Yeah, we'll call it, it takes 0.2 for an animation. We're going to have our frame counter, frame time counter, I guess. This is going to start out equal as 0. And, oh, and then current frame. Current frame is 0. So we start out on the 0 frame. And then we're going to add in frames until we hit the number of frames, and then we're going to loop back, right? So we have these 5 variables. We have the current sprite, or our base sprite. We have the number of frames for the animation, the current counter for the current frame, the maximum time for a frame, and the current frame that we're on at this moment. In fact, the current frame that we're on right now can go above the number of frames. There we go. Boom. You can name these whatever you want. We'll use these here in a moment. I'm going to do an animation section. We're going to say frame counter is plus equal to the d time. So we're going to add in d time. We're going to say if the frame counter is greater than the frame time, then frame counter is equal to 0 again, and the current frame, we're going to add 1 to it. We're going to say if the current frame is greater than the number of frames, then we will say current frame is equal to 0 again. Cool. And this only really happens, all of this is only going to happen if say if the number of frames is greater than 0. So if we have more than 0 frames, we're going to deal with this. If not, you don't even need to calculate any of this. If you only have 0 frames, you're not really doing any animation, right? So as long as you have greater than 0 extra frames, it doesn't mean you have 0 frames of animation. It means you have more than the first frame of animation. Now to draw this, I'm going to draw the player sprite, which is sprite number 1. Actually, that's SP. We're going to draw it at PX and PY. And we're going to add in the current frame. And that's it. Now when we run this, it looks kind of funky. I'm using pink as my background transparency color. So what I need to do is I need to tell the system that that I'm changing the transparency. So palt 0 is now not transparent, and I'm making color 14, that light pink, is going to be true for transparent. Also, the player position was a bit off. Notice how the player position is at the center of, or the drawing anyway is at the center of the circle. We need to subtract. So when we're drawing this picture, when we're drawing the player sprite here, this is draw player sprite, we're going to subtract 4 and subtract 4. There. So now the player's right in the middle. The only issue right now, of course, is that the background is the same color as his clothes. So maybe I can make him a different color. I might make him, maybe he has blue or something as his outfit color. Cool. Now, I don't want to draw the circle around him anymore, so we're going to get rid of this circle. Actually, let's put the player sprite up there instead of that. Boop, right there. So we got that, and actually, let's actually put that after the looking direction. All right, cool. So now the player is moving around. However, they're not animating. They're not doing any animation. They're not changing their looking direction. Well, in order to change the sprite, because remember we have this one looking right. Oh, and I guess we got to change all of these now to light blue as well. The dark blue shadow still works. Cool. Actually, we might make this kind of a light purple for the shadow color. There we go. Nice. In the Pico 8 program, the SPR function, you can add in more arguments. One is for the scale, or the next variable is scale in the X. The next one is scale in the Y. That's by total percentage, so 1 being 100%. And then whether or not you want to flip it on the X-axis and whether or not you want to flip it on the Y-axis. We're going to flip it on the X-axis. We're going to say flip. We're going to create a variable called flip. And flip is true if you're pressing, let's see, if you're pressing left. If they're looking left, so if your X direction is left, then you flip it. So we'll say local flip is equal to we'll say here's what we'll do. We'll say it's equal to dx, so direction x. If it's less than 0, If the direction x is less than 0, so -1, then true. So you're looking left. So we're going to say and true. Or if your direction x is greater than 0 and false. So if you're looking to the right, you're not flipping it. Or if nothing else, then if it's equal to 0, then it just equals itself. So let's see if this works. Looking left, looking right. If I don't push anything, it doesn't change the direction I'm looking. All right. And we want to have walking animation too. So what we'll say is, if you are inputting anything, then yeah. So if you're inputting anything, then we're going to say the number of frames is equal to 1, so 1 extra frame. Number of frames is equal to 1. And the current frame is, well, no, we'll do that. Number of frames is equal to 1, which is going to move it like this. And if you're not pushing anything, so here we'll say idling. So this is if you're not pushing anything. So if x is equal to 0 and y is equal to 0, so you're not, so the x and y axes don't have any input on them, then we'll say the number of frames is equal to 0, right? And then we're going to also reset the frame counter. Was that FC? Yeah, FC frame counter. This is going to be equal again back to 0. All right, so now when I move left and right, but if we don't input anything, then we want the current frame to be equal to 0. Okay, let's here's what I'm going to do. I'm going to move this looking direction vector. This is the looking direction vector that we're drawing. I'm going to move this a little bit. I'm going to take this part, this back part where it's pointing to, and I'm going to actually put it into the front part as well. Instead, it's going to start out as 8 pixels away from the player, and it's going to move to 16 pixels away from the player. Right? And then this one is going to do the same. Go out to 16 pixels away from the player, but it's also going to start 8 pixels away from the player. So this is going to be 8. This one's going to be 8 as well. And when we run it, there you go. So you can kind of see the player animating. We might want to adjust a couple of these. We're going to make this like 0.6. The anim time could probably be, actually that already feels pretty appropriate. It's a nice little walk animation. The only issue is when I walk up, it doesn't change the frame to the behind the back frame, right? So if we're pushing up, so we'll say, where do we do it? We might do it here next to the flip. Actually, we might say something like, if the direction y, if the forward direction y is less than 0, so you're looking up. Actually, we might do this. We might say SP, so the player sprite, is equal to, it's either going to be equal to 1 or it's going to be equal to 3. So either looking down or looking up. And it's going to be equal to, it's going to be equal to dy is is greater than 0 and 1. So if you're looking down on the screen, it's going to use sprite 1. or dy is less than 0 and 3, sprite 3, or if there is no direction y or whatever being used, then it's just going to stay equal to whatever current sprite it is. Cool. Now, when we move down or move up, or we go left and right, the only issue is when I move up, it doesn't flip left and right based on what I was last facing when I was facing down. So flip, got you. I think when we are moving up, we don't flip. It doesn't matter. Not a huge deal. You can always iron that out if you want on your own. But basically, you see moving left, moving right, moving up, moving down, attack, and it attacks out in front of the player. Now you can have. Oh, there you go. It is actually flipping it left and right from behind. So I'm looking up and attacking, looking left and attacking, looking down and attacking, looking right and attacking, right? So that's pretty simple. Now we just want to get the sword drawing at that attack position, right? At the damage position is where we want to draw the sword. So if we are in the attack state, we're actually going to draw the sword here instead. And the sword is sprite number 16. So I'm going to draw a sprite. Sprite number 16. It's going to be at x minus 4, y minus 4. And we're not going to draw a circle anymore. We don't need a circle. Cool. Now when I attack, it is in fact using a sword to draw where the attack is happening. But we're not drawing the sword effectively rotated. Notice when we start the attack, though, it is to his right and it is pointing away to his right. It's just when it's in front of him, you want it to angle in the direction in front of him. This part is maybe a little bit more tricky. So what we'll do is we will have a sword sprite. So we'll say sword is equal to 16. Right, that's the sword sprite. So what we want to do is we want to say, in the case where the sword is in one of 4 different states. So either we're looking down and the sword is to our right, we're looking right and the sword is in front of us, we're looking up and the sword is to our right, and we're looking left, or the sword is in front of us. So left and right, sword in front, up and down, sword to our right. Then we're going to want to change the sprite. So here, instead of sprite 16, we're just going to put in the sword sprite number. We will say if, actually we'll say, we can say if what are we trying to look at? We're trying to say if the player direction, so if the player direction does not equal 0, so meaning you are looking left or right. If you are looking left or right, and we're going to say APC is less than 0.5. So we're still in the early part of the attack. And we might even set a variable. We might set a variable here, a Boolean. We'll call it like, I don't know, like the first half of the attack. Like I might just call it first half. FH first half. I don't know. Yeah, we'll call it, yeah, first half is going to be equal to APC being less than 0.5 and true or false. So if it's in the first half, then it'll be true. This is the first half of the attack. Cool. So if the player is looking in the left or right direction, and they're in the first half of the attack, then that's going to be one part. Say, or the player is looking in either up or down, and you are not in the first half, then I think we can just say sword equals 17. This might, oh, sorry, 17. This might work. I think I got that backwards. Does look kind of funny though. So here this will be equal to 16, and we'll set this equal to 17. There we go. It's actually completely right now. The only issue is the direction it's flipping it. You notice if I look up, it's actually flipping the sword in the right way. By default, it looks to the right and it looks up. If I look left, I'm going to need to flip it on the x-axis, and if I look down, I'm going to need to flip it on both. If I look right, I'm going to need to flip it on the y-axis. So this doesn't actually need to be two lines. I could actually put this all on one line there. Put a parenthesis like that. So this here is sword sprite picking, and here let's separate this out a little bit. Draw the attack, and all right. So we're picking the sprite if you are looking in a certain direction, and depending on which part of the attack you're in, whether you're in the first half or not. And then we're going to add in this bit here. So 1, 1, and then we're going to say X flip, Y flip. Okay. Yeah, so we're going to flip it in the X, or we're going to flip it in the Y, depending on the direction we're looking. So local X flip, and local Y flip. And the way we determine whether or not we're flipping in the X, in fact, let's just set these to false for now. If you remember, if we're looking left, we're going to flip it in the X. And if we're looking down and it's in the first half, we're going to flip it in the X. So second half in left, down, or down in the first half. Second half in left, down in the first half. So we'll say X flip equals equals dx being less than 0, so you're looking left, and you are not in the first half, so not in the first half of the attack. Yeah, let's see if I'm doing this right. I may not do it like this. We'll set these equal to false. Hold on. Let's back up for just a second. Okay, so I'm just going to create two variables here. I can do this all on one line, but for readability's sake, I'm going to put x flip and y flip. The creation is going to be on one line. And then we're going to, let's see, sprite flipping. And this is all easily, this entire thing is completely useless if you use a sprite rotation function. But we're pretending like we don't have a sprite rotation function because we don't for this one right here. So imagining the simple way, you just have two sprites for rotating the sword. This is a simple way to do it. Or not that simple, but so we will say x flip is equal to let's say, or maybe if, yeah. So if the direction x, so you're looking to the left, but you're not in the first half, or your direction y is greater than 0, and it is the first half, then you can flip the sprite. Then x flip is equal to true. So basically this reads as if you're looking to the left, but you're not in the first half of the attack, or you're looking down and you are in the first half of the attack, then you are flipping in the x direction. And that's pretty simple. Now you can see the sword points in the right direction when I'm looking down, points in the right direction when I'm looking left in the first half. All right, now when do we need to flip it in the vertical? Well, if I'm looking down, I need to, and we're in the second half, we need to flip the vertical. And if we're looking right and we're in the first half, we need to flip the vertical. So first half and looking to the right, second half and looking down. So we'll say if, remember, so, and then we're going to have or. So we're going to have two parts for the first condition and the second condition. And if those are met, then y flip is going to be equal to true, right? So the first half, we'll just put it over here, is going to be if you are looking down, right? So if you're looking down, so your direction y is greater than 0, and you are in the second half, so not first half. Or if you're looking to the right, so your dx is greater than 0, and you are in the first half, then flip it. So you can see, oops, what did I do? Let me see. I said dh, my bad. If your dy, what do I say, dx. So if you're looking to the right and you are in the first half. So we attack, it's now rotating properly, we look right, and it's now rotating properly. Cool, pretty easy. And actually what we could do is we can change what the first half is here. So we're just saying you're in the first half if it's less than 0.5. We say like less than 0.4, it'll start rotating earlier. Now it'll say like the first half is until 40% of the first 40% of the attack is the first half or something. You can see it starts to rotate earlier. So kind of tweak it a little bit in that way. But there we go. Now we have a really simple attack, and you can use the damage position to determine where you break stuff. Let me just show a real quick example. So let's not draw these lines. I'm just going to comment them out. I'm not going to delete them in case you want them later. So you can see, start walking around, can go into the attack state. You can even choose that when you're in the attack state, you use like a different frame of animation. Maybe you animate the player differently, right? So we have the animation handling variables that you can use for if you want to play out like a different animation when attacking. Let's destroy something, right? So we have this bush here, and this color back here, this color 11. So I'm going to make a background. Actually, I'm going to make the background be the color 11, right? So we're in this green, very bright green space, and I'm going to draw some trees. Let's draw some trees here, like this, right? Some simple little bushes. Okay, and I'm going to set a flag. Oh, I already do. I have this flag here, flag 0, that's set. So this is how we're going to know if it's a tree. If the flag is 0, we know it's a tree. If it's true, if flag 0 is true, then we know it's a tree. So when we go to attack, I'm going to say, when attacking, here's how we'll do it. We'll say the damage position, which we have. Let's see, local x2, y2 is going to be equal to damage position. All right, so it's going to be the same between when you were drawing and when we're actually calculating where the damage is going for the environment. And first, before we do anything more, let's draw the map in the background. So instead of clear screen, right after it, I'm going to put the map. Right, so here we actually have the map. Now, there's no collision right now, but you can see I can attack bushes. Let's actually destroy the bush. So here in the attack state for the character, we have gotten the attack or the damage position, the attack position, right, of the sword. And so what we'll say is we will get the map position. The way we do that is we're just going to divide it by 8. So we will say x2 divide equals 8, and y2 divide equals 8. That'll give us the actual map position. And we're going to use an fget function. We'll say if fget, and we're going to give it the tile that we're on. So the tile is this tile here. Here, I'm going to calculate a tile. Tile is equal to mget x2 y2. Oops, y2. We're going to put in the tile, and we're going to tell it if the 0 flag is true. So basically this reads, if flag 0 is true for this tile that's at this position, then we are going to mset that position, x2, y2. We're going to set it to 0. All right, let's see how this works. There we go. So we already can start clearing stuff. Now, again, there's no collision. You can add in collision, but now we have something that's destroying objects, and it even destroys it in the second half. Now, the way we calculated the second half of the attack, you could have it do no damage in the first half, and only in the second half, or you can have it do damage at any point during the animation you want. Again, you just do a little if statement or check, perhaps, to see if we're in the first half or the second half, or whether or not that value is true that we made. But there you go. Simple sword swing. Thank you for joining along and watching, and I hope you have a good rest of your day.